Welcome back. We will continue the discussion on hydraulic circuit elements. In the last session, we have seen how to draw the symbolic representation of the energy conversion elements like pump, motor, air motor, etc. So today, we are going to see first the hydraulic cylinders, which converts pressure energy to mechanical energy. So there can be two different types of cylinders, single acting or double acting, depending on which side of the piston the fluid is acting. So single acting cylinder means, hydraulic cylinder means the fluid will be acting on one side of the piston only. Other side will not be having any effect on fluid. So when the pressure by the fluid is acting on this side of the piston will be moving towards the right side, and when it is pressurizing the fluid, the fluid will be released to that inlet, that line. So usually the line of the fluid is represented by this continuous line, and the cylinder with a rectangle with an opening for the piston rod, and the piston with a rectangle inside the cylinder, and the piston rod is again another rectangle with open end on the other side. And the return action of the piston can also be caused by a spring. So that is usually represented by the wound spring over the piston rod is represented by these zigzag lines. Now coming to the double acting cylinder, the fluid line will be there on either side of the piston, or the fluid pressure will be acting on both sides, top and bottom of the piston. But you can observe here the piston area is not the same on either side. Here the effect of this piston rod will reduce the area, right? Now in the second category of double acting piston, you can have the piston rod on either sides. On either sides of the piston, you can have the piston rods, and the piston area will be identical in this case. Now, in order to maintain the clearance volume here, you can have a cushioning effect so that the piston will not hit on the top of the cylinder. So you can have this cushion on one side or two sides. So that is represented respectively like this. Now coming to the energy transmitting elements, that is the lines through which the energy in the form of fluid flow is transmitted from one major element to the other major element. So these are the different types of energy transmitting elements. So in general, main working line is represented with a continuous line with solid filled arrow, and the pilot line or control line is represented by with a continuous line with open arrow. That means no solid fill. And the drain line, if you need to drain the fluid from a tank or as a reservoir, that is usually represented by the dashed line. And a flexible connection line is usually represented like this: a continuous line, a solid fill dot, an arc like this, again a solid fill dot, and a horizontal line. Now a junction where two streams of fluid are mixing at perpendicular to each other is represented by a dot at the junction. So that means the fluid from this line and fluid from this line will be joined here and flowing together. So here also mixing takes place of these two lines. Now coming to the next one, the crossed line with no connection. If there is no connection between the two fluid streams, so there are two perpendicular lines through which fluid is flowing, but there is no connection, that means there is no dot, solid fill dot will be present at the junction. So again, this is not a junction, but one line will be flowing over the other. So from this second diagram, it is clear. So you can represent either like this or like this. Both are correct. And if the end of the line is blocked or closed, there is no outflow. There is no further. There is a terminal that is represented by this cross. That means it is a pressure line with plug. Okay, there is a plug is attached at the end of this line. Now coming to the coupling, so this vertical line represents the coupling in open position. If these two lines are joined with this coupling, so one line is there, one line is there. Okay, these are the valves. Fine. So valves are in open position. There is no contact between this circle and these slanted lines. That means the valve is in open position so that the fluid can flow through this coupling to the other line. Fine. So in this condition, this coupling is in open position. When the coupling is uh, disconnected, when the coupling is disconnected, you can see that the valve is closed. Valve is closed. Okay. So coupling is disconnected. So there is no connection between this line and this line. The valves are closed, so no fluid can flow in this direction or no fluid can flow in this direction. Fine. Now coming to the fluid storage elements, where you need to store the pressurized fluid or fluid for transmission. So usually we represent storage tank of usually in the form of a rectangle, again similar to the cylinder. A pressurized reservoir is represented by a rectangle. If it is a vented reservoir, if it is open to the atmosphere, it is represented by like this, a rectangle without the top portion. And if there is a tank with level indicator to indicate how much fluid is there, and with an air bleeding line, if a pipe with an opening to the atmosphere, that is represented like this. This is for the level indicator and this is for the air bleeding. Now an air storage tank on the other hand is represented by a rectangle with edges curved like this with a gauge, pressure gauge. So that's all for today's session. In the next class, we will see different types of valves. The flow controlled valves, pressure controlled valves, all these things will be discussed in the coming session.